First up, let's talk about the METAR, which stands for Meteorological Aerodrome Report. Think of it as a concise, coded snapshot of the actual weather conditions at a specific time and location. You'll typically see these issued every half hour to keep you updated. The very first group you'll spot in the report is the type indicator. In this case, it's clearly marked as METAR. Following that, you'll find the 4-letter ICAO location indicator. For this walkthrough, we'll use the example of King's Bridge. Next, we move to the date and time group of the observation. The first 2 digits give you the date, followed immediately by the time in UTC. Now, let's dive into the wind information. First, you'll see the direction, expressed in 3 digits representing 10-degree intervals. Remember, this is measured in degrees true, followed right after by the wind speed. Keep an eye out for a gust figure preceded by the letter G. This appears if the gust speed is at least 10 knots higher than the mean. If those gusts happen to exceed 99 knots, you'll see the abbreviation P99 used instead. Finally, the last letters confirm your units of measurement, either meters per second or knots. The next section might appear depending on whether the wind is showing directional variability. This group highlights the extremes in wind direction recorded over the past 10 minutes. You'll see the letter V sitting right between those 2 directional values. Next up is the visibility group, represented in meters. In a meter, this value specifically refers to the prevailing visibility. Let's dive into prevailing visibility. This is defined as the visibility value that covers at least half of the horizon circle or at least half of the aerodrome surface. When we are talking about distances up to 10 kilometers, we measure this precisely in meters. For instance, if you see the code 0450, it means the prevailing horizontal visibility is 450 meters from your observing point. Once conditions improve to 10 kilometers or more, we use the simple code figure 9999. Now, here is an important rule. If the visibility in a specific direction is less than 1,500 meters or less than 50% of the prevailing visibility, we have to report that lowest visibility along with its general direction. For example, imagine a prevailing visibility of 3,000 meters, but with a minimum visibility of 1,400 meters to the southwest, we'd report both. Sometimes, you'll also encounter runway-specific visibility information. We call this the RVR, or Runway Visual Range. We only include this in the report when the prevailing horizontal visibility or the RVR itself drops below 1,500 meters. This group starts with the letter R, followed by the runway in use, and then the threshold visibility. Let's look at King's Bridge. If the Met visibility is 2,000 meters, but the RVR on runway 27 right is 1,700 meters, we report both to give a complete picture. Keep in mind that visibility on the approach path can be quite different from the general horizontal visibility. That's exactly why, in poor weather, the RVR becomes such a vital piece of information for your approach. Just a quick note, RVR is reported for the touchdown zone only. You might see RVR reported as P1500, which simply indicates that the visibility is greater than 1,500 meters. In some regions, you'll see a letter appended to the RVR to indicate the recent trend. A U signifies that the visibility has increased by 100 meters or more over the last 10 minutes. A D indicates a decrease, while an N means there is no distinct trend at all. Occasionally, you may see the 1-minute maximum and minimum values reported as well. For example, on runway 27 right, the RVR might show a 1-minute mean that fluctuated between 1000 meters and 600 meters during that 10-minute observation period. And, generally speaking, it's on the rise. RVR values are typically captured automatically, derived from complex equations that account for ambient light levels, runway light intensity, and the expected detection sensitivity of the pilot's eye. Next up is the weather group, which tells us exactly what's happening at or near the aerodrome at the time of the report. Let's dive into an example to see how it works. We can break this weather group down into 3 distinct parts. That plus sign is our qualifier, and in this specific instance, it denotes heavy. Next, the sh serves as the descriptor. In our example, sh stands for showers. Finally, we have RA, which represents the actual weather phenomenon, rain. Put it all together, and we have a heavy rain shower. Now, that's just one example, but there are plenty more. Here is the complete list. It might look a bit intimidating at first, but it's actually quite straightforward once you break it down. Let's walk through each column together. Simply put, the first 2 columns use letters or symbols that act as qualifiers. The last 3 columns define the specific weather phenomena. Don't worry if it sounds confusing, everything will become crystal clear as we work through them step by step. The first column focuses on intensity or proximity. There are 4 key members in this column to remember. We have minus, plus, VC for in the vicinity, or no entry at all if there's no qualifier needed. We'll see how the entire weather group functions together in a moment, but for now, let's move on to the next column, the description. Each element in this column provides extra detail or helps describe the weather phenomena we'll be covering shortly. The one little exception is TS, which stands for a thunderstorm. You can use this on its own without needing any additional groups, but we'll dive into that in a moment. As we mentioned, those final 3 columns represent our weather phenomena. Let's walk through each of these columns one by one and explore how they're actually used. Starting with the third column in our table, we focus on precipitation. This group is quite intuitive, as it covers all precipitation types like drizzle, rain, snow, hail, and so on. Moving on, the next column covers the obscuration of the atmosphere. Just like the last one, this is pretty self-explanatory. You might find it interesting that some of these letters actually come from French words for the phenomena. Learning the origin can be a great memory trick. For example, let's look at BR for mist. It actually originates from the French word for mist, which is broom. The final column captures all the remaining weather phenomena that didn't fit into the previous categories. This group is mostly for those rarer events. They don't show up often, but they are incredibly important for you to recognize. And with that, we've completed our look at the weather group of the meter. I know it might seem a bit complex at first, so let's look at how these symbols and letters work in practice. We'll start with some straightforward examples and gradually build up to the more complicated ones. As you gain experience with the code, you'll find that the most common entries will quickly become second nature. Of course, for those unusual groups, don't hesitate to check your notes or a quick reference guide. Now, let's see how we would encode a light shower of rain. We use the following symbols and letters to represent this phenomenon. Starting with intensity, followed by the descriptor, and then the actual precipitation type, like light, shower, or rain. So, This string tells us that a light shower of rain is impacting the airport at the time of the observation. As you can see from this example, you don't necessarily need to pick a member from every single column. The golden rule is that each weather group must contain at least one, and perhaps up to two members, from the weather phenomena columns. Specifically, we are looking at columns 3, 4 or 5. Keep in mind that while there can be a qualifier, it is not strictly required. For instance, let's imagine